And before carrying out these exercises in smaller breakout sessions, I would like to give you a short introduction what participatory system mapping is about. So when we talk about system mapping, just if we take the two words, system mapping, systems as a combination of things or parts forming a unitary whole, and mapping as an act of making a map. Just a very easy example to start, and I just took a very simple example because we talk about growth, and we could now talk about economic growth, but to make it very simple, we can also talk about physical growth, growth of the body mass index. So if I just think of my own body mass index, I think there's a certain balance of input, of food consumption, and of doing some exercises, physical activity. So as long as this is in a well balance, I'm in shape. But there are certain broader things that could happen. So this would be a very easy model, but if we take one step back, this food consumption might be influenced by the level of stress and frustration. The more frustrated I am, the more chocolate I eat. The more chocolate I eat, the fatter I get. The fatter I get, the more frustrated I am. We could call this the frustration loop. So this is a sort of reinforcing loop. Systems perspective means not just to have a look at the individual items, but to take a systemic point of view. But we have this aspect of physical activities as well. So the more I practice, the more I lose weight. The more I lose weight, the more emotional support I get from my partner. The more emotional support I get, the more physical activity I practice. So we have this supportings loop as a second loop. So we have two loops. One about frustration, one about partner's motivation. So how could we steer such a system? So there might be some doctors or experts or policies telling us how we should behave, telling us that it's very good to exercise, that it's good for your health, that it reduces your weight. But there also might be some other experts, habits or ads telling you when you're frustrated, take a chocolate shot. And everything's fine, so there might be new products so that you can have a chocolate shot immediately after finishing a very annoying telephone call. So this might change your habits. And some ads telling you that it's good after each telephone call to have one chocolate shot. Having seen the whole system from an even broader perspective, some values, for example serenity, might change both. So if you're more relaxed, you reduce the frustration loop and you improve the partner's happiness loop. So this is a way of system mapping. Very easy example. If we do it without pictures and without jokes, it looks a little bit different, it looks a little bit more scientific. And I want to tell you a little bit about what are the benefits of this kind of system mapping and how can we produce system maps together later on in the afternoon. So there are certain fundamentals we have to keep in mind. A system map is a sort of conceptual model that represents some elements, and it for sure has a certain kind of interdisciplinary approach. So it allows us to share perspectives from very different views in one picture, and building this map reveals a certain kind of underlying structure. So in building this map, we go from the surface, where we talk about events and patterns, to the structures that cause the patterns to be maintained. So reinforcing loop, balancing loops, and so on. When we do this system mapping in a participatory way, we use it to capture the perceptions and mental models of the people involved, and to expand the boundaries of our thinking. And this is why the learning process and the exchange process is equally, if not more important than the resulting diagram. This is why we applied it in the Responder project, because Responder is about knowledge brokerage. So how will we build up such a system map in the given time? We will have about 1.5 hours. We will work in smaller breakout groups. So there will be about 12, 15 of you in each group, moderated by a well-trained moderator. First, we need to know what are variables, what are causal links, what are delays, and what are feedback loops. Basically, this is a kind of language that we will use. It's a sort of formal language, how we can jointly prepare and develop such a system map. So when we talk about variables, Variables actually, they are factors that help to explain a particular problem. For example, if the problem is how does a fisherman boost his sales, the variable might be fish catch. The variable itself has to have certain characteristics. It has to be precise. So for example, sustainability wouldn't be a very good variable. Or sustainability is a very, very broad and very fuzzy concept. It would not be precise enough. And the variable should be without any direction. So not higher fish catch, more fish, or less fish. The direction then is in the system map in the arrows, not in the variables. So variables should be precise and they shouldn't have any direction in themselves. Second, we need causal links. Causal links are the arrows between the cards. The variables will be written on cards, and then there will be some arrows in between. And these causal links, they might be positive causal links or negative causal relationships, which means they are not just correlation, they are real causal connections, causal relationships. This means, the positive causal relationship means if one variable goes up, the other variable goes up as well. That's a positive link. The other way around, if one variable goes down, the other one goes down as well. They go in parallel. For example, if fish catch goes up, without fishermen, his sales go up. The polarity of this causal relationship is marked by a plus, meaning it is a positive relationship. It's not a normative statement saying that we think it's good or not good. It just is a positive causal link. There might be some negative causal links as well, and they just mean that the relationship is inverse. If one variable goes up, the other one goes down, and the other way around. If this variable goes down, the other one goes up. For example, if price of fish goes up on a market, demand for fish goes down. The other way around, if price of fish goes down, demand for fish goes up. I think that's very easy. Sometimes it's difficult to keep in mind that positive means positive in both directions. Both goes up, both goes down. And negative means it turns around. So if this one goes up, the other one goes down. You have to be rather precise in preparing system maps with the plus and the minus, because if you lose track on what is plus and what is minus, the whole system map is not really reflecting what you want to map. Then we have one more element of our syntax, which is delays. Time delays can be indicated in a way that there is a relationship, positive or negative one, but the effect has a certain kind of delay. And in the end, when we have all of these relationships, all of these positive and negative ones, sometimes you find some loops. So this means that you have circular causalities, and this provides the system with a continuous dynamic. These can be positive or negative feedback loops. Actually, you can identify them when we have a look at the bigger map. For example, such a positive feedback loop, which is also called reinforcing loop, concerning our fishermen, if number of boats go up, they catch more fish. If they catch more fish, their sales increase. If their sales increase, their wealth increase. And with a certain kind of delay, they are able to buy more boats. When they have more boats, they catch more fish, they sell more fish, they have more money, they buy more boats. You see, this is a positive loop, this is a reinforcing loop. Systems that are shaped by reinforcing loops normally go for exponential growth or exponential decay. It can also be done the other way around. So if a number of boats go down, they catch less fish, their sales go down, their wealth go down, they can't afford to buy or to repair their boats, the number of boats go down. So it can also be the other way around. It does not mean that it is exponential growth. It can be exponential decay, but it's exponential because it's a positive feedback loop. Another example, when you have certain plus and minus within such a system, then you could identify so-called balancing loop. They are self-regulating, they are stabilizing. For example, when we take into account the fish stock, in our case of the fisherman, if fish stock goes up, fish density goes up. If fish density goes up, fish catch per boat goes up, total catch go up, but now we have the negative loop. If total fish catch goes up, fish stock goes down. So in this case, we do not have any exponential systems behavior. The system fights against its initial move, and therefore it's balancing and it's stabilizing. That's all we need to know. This is all what we have to build up our system map. Sometimes feedback loops are often invisible. This is why sometimes it's important to have a broader view on the whole system, because the feedback loop might affect in the end the initial move. So what can you get out of this experience? You can take a broader view on the whole system. You can mutually understand the worldviews of other participants. You can even bridge a gap between research and policy making, because there might be different rationalities shaping the worldviews of researchers and policymakers. You can try out this method, and you will be guided by experienced moderators. We will have 3 groups, and I think when you came to this event, you already registered for one of the groups. The first group will be moderated by Frida Rubik. Just please, Frida, stand up so that everybody knows who you are. Okay, if you want to go to, or if you plan to go to this group, just follow Frida. He will work on the question which effects might increase fuel prices have on the EU27 car fuel consumption. So we have on the one hand the fuel prices, and on the other hand the car fuel consumption, and we will map the system standing behind or linking these two variables. My group, which was, Frida, where will you go? You will go in this direction. Okay, so if you are in the first group, you will then later on, after coffee break, follow Frida this direction. My group, which is the second group, will work in this room. We will work on the question, how does road construction influence transport volume and road split? So it's much more about spatial planning, urban planning, road construction. And Gerhard Berger, our third moderator, Gerhard, please stand up, please. He will work with you on the question, have the car scrapping premiums introduced in some European countries reduced the environmental impact of the car fleet? And this group will work in this direction. This is the third group. So you will have this guiding question in the group work. The guiding question, actually, your work will start with 2 cards, and they will be part of the guiding question. For example, when we talk about the effects of increasing fuel prices on the car fuel consumption, you have 2 cards, you have 2, not called system boundaries, but implicitly they are system boundaries. We did not dare to have a clear system boundary, because then we could talk about system boundaries for hours or even days, but implicitly the 2 cards, they show a starting point and an end point. And if you want to develop the map around the cards, you're free to do that, but the moderators will push you to link the 2 cards, because that's basically the guiding question. Because the system map will be developed mainly between these 2 cards, and they frame the issue. Like that. The moderation of such a system mapping group is very different to moderating with other moderation techniques. So when you use Metaplan, or you use creativity techniques, or however, or brainstorming, most of the times brainstormings try to motivate you to produce as many cards as you can. And that's not the way it is in system mapping. It's not about the mass of cards you produce, it's much more about focusing on the issues which you think are really important. So the moderators will guide you, and they will try to focus the whole group on the issues which are discussed. And they will try to connect these cards with arrows so that we come up at the end with a systemic view on this part of the mobility system. The first exercise takes place today. It starts at 3:45. It takes 1.5 hours, so we will have a coffee break, and then we can go into these breakout sessions. The moderators will briefly reintroduce you into the system mapping method, and if you have any questions, please ask the moderators. Then you will elect a presenter and a rapporteur. They have 2 different roles, because tomorrow, in the second exercise, you will switch to other groups, and the presenters and the rapporteurs will stay with their own group. So 2 of you will stay with the moderator, and the others then tomorrow will go to other groups to learn what happened in these other groups. So therefore it might make sense in the very beginning to elect the presenter and the rapporteur. And then, within these 1.5 hours, you will develop a system map trying to answer your guiding question. Tomorrow, there will be 2 rounds of presentations of the maps to the other working groups. This will be a sort of rotation. You will have half an hour in one of the other working groups and a second half an hour in the other working groups, so that you get to know what the other groups have been doing today. Then you will come back to your home group tomorrow, and you will review the map on the basis of the received feedback. And at the end, we will do a certain kind of voting exercise on knowledge gaps, but this will be explained to you tomorrow by the moderators. There are certain ground rules for system mapping. You have to keep in mind that a model is an abstraction of reality. A model is a model, and it is not reality. It is just a map. We produce a map that mirrors our perceptions of the world, and it's a product of a team learning experience. As it is a team learning experience, participants have the right and responsibility to be unique. So you're invited to allow ideas to exist and to grow without to withhold judgments, at least for a certain time. And you will be guided by some moderators that will cut off monologues and try to create an exciting atmosphere, because it's a group exercise and it's not about giving presentations. It's a joint work on this system maps. Yeah. That's it from my side. Just to explain the system mapping, I can tell you it really works out. We tried it several times in different settings. It's an interesting experience. It's very good for interdisciplinary work, and you will experience this after the coffee break. Thank you.